Friends, welcome to my channel. Dhanesh here.
In this video, I am going to do a movie sentiment analysis uh, using neural network. Sentiment analysis or opinion mining. Opinion mining is a natural language processing technique used to determine whether data is positive, negative, or neutral. Sentiment analysis is often performed on textual data to help businesses monitor brand and product sentiment in customer feedback and understand customer needs. So here, this is the data set I am using. You can download the data set from this link using the Keras embedding layer and glow word embeddings to glow word embeddings to convert text to numeric form. Anaconda, here I have the TensorFlow underscore CPU channels. I am using that, and you can create different channels. I have base and Python 36. So this is for doing the quantum computing programs, and here it is TensorFlow CPU. It is there. So I have launched the Jupyter notebook from here. So I have imported pandas, NumPy, NLTK. If NLTK is not installed in your machine, you can give a pip install NLTK, then it should be installed. I am getting the one hot encoding from Keras and pad sequences, the different layers, activation, dropout, dense, flatten. So most of the modules I have, train underscore test underscore split from the sklearn for splitting the training and the testing data set, and I have got the tokenizer from the Keras for tokenizing the words. If you are familiar with NLP, you may be familiar with tokenization, lemmatization, stemming, all these aspects. Let me run this. See, yeah, it's fine. It's working fine. Next, what I'm going to do is just see. You can see the message using TensorFlow as backend. First, we will import and analyze the data set. Let's now, import the data set. I have saved, I have shown you the link. So I have downloaded the CSV file from that, link from that web page, and it is saved in my local system. So let me, analyze. We will just analyze the data set. Let's do. You can see it here. It's I have saved the data set inside, decode and tatomasi, repeat machine learning sentiment analysis asset. This is the path you can this is the path I have given in the program. So this I have downloaded, this data set I have downloaded from the link I have shown previously. So I am using the yeah, you can see here you have, it's only the first so it starts from 0. So you have the first 5 rows, both positive and negative sentiments are there. You can see the reviews. See, let's now look at any one of the reviews so that we have an idea about the text that we were going to process. Look at, see, you can see here, basically there is a family where a little boy, so the text you can read it here. So this is the review. So the review, that what I have done is, one of the reviews, just I printed it so that I can get a feel of the, text we are going to process. So that's what I have done. You can see that our text contains punctuations, brackets, and a few HTML tags as well. We will pre-process this text in the next section. Um, let's see the distribution of positive and negative sentiments later in our data set. First, we will pre-process the data. For that, I will use the Seaborn library. So I have I'm running it. You can see the output here. So what does it mean? If you see here from the output, it's clear that the dataset contains equal number of positive and negative reviews. Now we will get into the data pre-processing. We saw that our dataset contained punctuations and the HTML tags. In this section, we will define a function that takes a text string as a parameter and then performs pre-processing on the string to remove special characters and HTML tags from the string. Finally, the string is returned to the calling function. So let's write that script. We will do that. So this is the method we are using. Yeah, it's working now. So if you see the method in the preprocess underscore text method, the first step is to remove the HTML tags. To remove the HTML tags, remove underscore tags function has been defined. The remove underscore tags function simply replaces anything between opening and closing with an empty space, that braces opening and closing brackets with an empty space. Next, in the preprocess underscore text function, everything is removed except capital and small English letters, which results in single characters that make no sense. For instance, when you remove apostrophe from the words marks, the apostrophe is replaced by an empty space. Hence, we are left with a single character yes. Next, we remove all the single characters and replace it by a space which creates multiple spaces in our text. Finally, we remove multiple spaces from our text as well. Next, we will So the pre-processing of our reviews, and we will pre-process our reviews and store them in a new list. So I will write the script for that. Let me run this. Yeah, it's working fine. So let's now see the fourth review. We can see the output is like this. So from the output, you can see that the HTML tags, punctuations and numbers have been removed. We are only left with alphabets. Next, we need to convert our alphabets into digits since we only have two labels in the output, that is positive and negative. We can simply convert them into integers by replacing positive with digit 1 and negative with digit 0. So I will write the script. Let me run it. Yeah, it's fine. Sorry. Finally, we need to divide our data set into train and test sets. The train set will be used to train our deep learning models, while the test set will be used to evaluate how well our model performs. We can use the train underscore test underscore split method from the sklearn.model.selection module. I will write the script for that. The script, so let me run this. So the script divides our data into 80% for the training set and 20% for the testing set. Now write the script for our embedding layer. The embedding layer converts our textual data into numeric data that is used as the first layer for the deep learning models in Keras. So next is the preparation for the embedding layer. See, as a first step, we will use the tokenizer class from keras.preprocessing.text module to create a word to index dictionary. In the word to index dictionary, each word in the corpus is used as a key, while a corresponding unique index is used as the value for the key. Let me write the script for that. Let me run this. So if you view the x underscore train variable in variable explorer, you will see that it contains 40,000 lists where each list contains integers. Each list actually corresponds to each sentence in the training set. You can also understand that the size of each list is different. This is because sentences have different lengths. We set the maximum size of each list to 100. You can try a different size. The list with size greater than 100 will be truncated to 100. For the lists that have length less than 100 we will add 0 to the end of the list until it reaches the maximum length. This process is called padding. You may be familiar with when you discuss about you know convoluted neural networks and all, padding and stride you may be familiar with. So let me write a script that finds the vocabulary size and then perform padding on both train and test set. So this is the script I have written for the script finds the vocabulary size and then perform padding on both train and test set. It's working. So now if you view the x underscore train or x underscore test, you will see that all the lists have same length, that is 100. Also the vocabulary underscore size variable now contains a value 92547, which means that our corpus has this much words. Now we will use globe embedding to create our feature metrics. In the following, in the coming script, in the script I'm going to write, we load the glow word embedding and create a dictionary that will contain word as keys and their corresponding embedding list as values. Let me write the script. Let me run this. See. So we will create an embedding matrix where each row number will correspond to the index of the word in the corpus. The matrix will have 100 columns where each column will contain the glow word embedding for the words in the corpus. Let me write the script for that. So once you execute the above script, you will see that embedding underscore matrix will contain, 92547 rows, one for each word in the corpus. Now we can recreate the our deep learning models. Use recurrent neural network for classification and the sentiment analysis. A recurrent neural network is a type of neural network that is proven to work well with sequence data. Since text is actually a sequence of words, a recurrent neural network is an automatic choice to solve text-related problems. Here I am using LSTM, long short-term memory network, which is a variant of a recurrent neural network to solve sentiment classification problem. Let me run this code. Yeah, it's working fine. In this script, we started initializing a sequential model, followed by the creation of the embedding layer. Next, after that, we created LSTM layer with 128 neurons. You can see the model summary here. So once the next step is to train the model on the training set and evaluate its performance on the test set. Let's do that. Let me run the script. Yeah. So this script trains the model. Let me run the script. Yeah, it's giving a test score of 0.33 and test accuracy it is 0.855. So you can see it here, the we can see there is a very small difference between the training accuracy and test accuracy, which means that our model is not overfitting. So let's plot the loss and accuracy difference between training and test set. Let me run the script. So if you see here, see the graph is, you can see it from the graph. It's there is a very small difference in the training and the test, in the model accuracy and model loss. You can see it in the plot. So the output shows that the difference between the accuracy values for training and test set is much smaller. Similarly, the difference between the loss values is also negligible, which shows that our model is not overfit. We can conclude, see, see, we have used RNN here. See, which is the best option, which is the, RNN is the best algorithm for text classification. Even in our different videos, we use the simple neural network and convoluted neural network for text classification. The best approach you can go for is RNN. So it's the here the model is not overfitting. If you want to predict on a single instance, see how to make a prediction on a single instance or single sentiment, you can write this script. So this is the text, this is the output. So I'm going to, use the code. I'm going to write the script, so you can see it as a negative review. To predict the sentiment of this review, we have to convert this review into numeric form. We can do this using the tokenizer that we already created in the word embedding section. The text underscore to underscore sequences method will convert the sentence into numeric counterpart. Next, we need to pad our input sentence as we did for our corpus. Finally, we can use the predict method of our model and pass it to our processed input sequence. So let's write the code. When you run this, see, you will get the output array. This is the output. See, we map the positive outputs to 1 and negative outputs to 0. So the sigmoid function predicts floating value between 0 and 1. If the value is less than 0.5, the sentiment is considered as negative, whereas if its value is greater than 0.5, the sentiment is considered as positive. Here you can see here it is 0.34, so the sentiment value for single instance is 0.34, and which means that the sentiment is predicted as negative. You already saw the negative sentiment. So text classification is one of the most common natural language processing tasks. So we discussed in this video using RNN, that is LSTM. That's all about how to use LSTM for text classification.
Thanks for watching. Please like, share and subscribe. Thanks a lot.